Hello friends, I welcome you all for my lecture on numerical method based on interpolation formulas. Dear friend, for your semester number 3, you have an experiment paper. The code of this paper is Physics 3503L, where L stands for laboratory session. You have to perform one one experiment which is based on interpolation formula. Basically, this is a computational exercise. I would say it's a numerical exercise which you have to perform with the help of ordinary calculators, or you can use Excel sheet. This is an exercise to perform interpolation. So before I proceed the exercise, I will give you a brief introduction about interpolation. And here you people have to use a Newton's formula for the interpolation. There are two formulas proposed by Newton. Newton forward formula for interpolation and Newton backward formula for the interpolation that I will explain. What is the term forward indicated, what is the term backward indicates. The derivations of these two formulas are given in the textbook. The name of the textbook is Numerical Methods in Engineering and Science. The author of this textbook is B.S. Grewal, and the publisher is Khanna Publishers. So I will not give you the derivation of the interpolation formula, but today I will explain how to do interpolation and how to use these two formula for the interpolation. And I will give you some remarks on extrapolations also. So friends, if the data are given in a tabular form with the value of x and y, where y is a function of x, at a certain interval of x, you can see here the table where the value of x are given x0, x1, x2, x3, x4, xy, and the values of y, which is a function of x, is given y0, y1, y2, y3, y4, and so on. And suppose the value of y is needed for some x. You require some value of y for some x which is not listed in this table. So generally, the simplest procedure is that we plot a graph of y against x. We draw a smooth curve, and from the points, and we read from the graph the required value of y for a given x. The same results can be obtained by the use of interpolation formula, provided the given values of x are at equal spacing. That is the condition. So first of all, I will give the definition of interpolation. So friends, you know that the values of x and y's are given, where y is a function of x. Then the process of finding the value of y corresponding to any value of x, let us say x equal to xi, where your xi is lying between x0 to x6, and this procedure is called interpolation. Once again, I'm repeating the process of finding the value of y of corresponding to a value of x, let's say xi, where xi is lying between the interval x0 to x6 is called the process of interpolation. And the process of finding the value of y for a given value of x, where x that is xi, where xi is not lying between x0 to x6, then this procedure is referred as extrapolation. So here you have to prepare first a difference table for the interpolation. Here we are using the method, Newton's interpolation method for equal intervals. Here you have the value of x0, x1, x2, x3 are equally having equal intervals. That means x1 minus x0 is equal to h, x2 minus x1 is equal to h, x3 minus x2 is equal to h. You have an equal interval. So first of all, I will explain that this difference table, we first find first order difference delta to the power of 1. We find second order difference delta to the power of 2. Third order difference delta to the power of 3. Fourth order delta to the power of 4, delta raised to 5. And the sixth power. Here I will define a delta y0 is simply a difference of y1 minus y0, where you have to take care about the sign. If y1 minus y0 is minus, you have to write down that minus sign. So you have to take care about the sign. Delta y1 is y2 minus y1. Delta y2 is y3 minus y2. Delta y3 is y4 minus y3. Delta y4 is y5 minus y4. And similarly, delta y5 is y6 minus y5. So this is the first order difference. Then you have to find the second order difference. Second order difference is del square y0, where del square y0 is del y1 minus del y0. Del square y1 is del y2 minus del y1. Similarly, del square y2 is del y3 minus del y2, and so on. Similarly, you can find the third order difference is del 3y0. So del 3y0 is del square y1 minus del square y0. Del 3y1 is del square y2 minus del square y1. And same way you can find del to the power of 4y0 is del cube y1 minus del cube y0. And the same way you can find the fifth order del 5y0 is del 4y1 minus del 4y0, and so on. You can find del 5 y1. And finally, the sixth order difference del to the power of 6y0 is del 5y1 minus del 5y0, which you can calculate. So you have to prepare your difference table, and here I have mentioned the first order, second order, third order, and kth order difference. I write the general formula, which is already I have mentioned. You see, I mentioned delta y0 is y1 minus y0, And similarly, delta y1, I said y2 minus y1, and you can see delta yn minus 1 in the same way is yn minus 1. This is a general formula. Similarly, you can find del square y0. Del square y0 is delta y1 minus delta y0, right? Delta y1. And delta y1, we know y1 minus y0, and delta y0 is, we can see delta y0 is y1 minus y0, and we can find delta y1 is y2 minus y1. And if you substitute the value, you will get y2 minus 2y1 plus y0. I hope you can understand this step, which once you understand this difference table, similarly you can find del square yn, del cube yn, where n runs from 0, 1, 2, 3, 4, 5, 6, and so on. Similarly, if you can find del to the power of r yn, a general formula, one can write this formula using the symmetry. So once you know this expression, I think this expression one can write using the symmetry. One can write these expressions. Now, uh, in forming such a table of difference, you have to take care about the sign. The subtraction must be performed in the order which is given by this expression. Say delta y0 is y1 minus y0, right? Delta square y0 is del y1 minus del y0. So as I say, I already explained you that whenever you find a first order difference or a second order difference or third order difference, you have to take care about the sign, which is very important. And that's why I have mentioned here that the sign should be considered when you find the second order difference, third order difference, or a first order difference here. You see now I define the two variable xk and yk, which I will discuss what is xk and yk represent. Now, if xk and yk are the given value in a table, let's say I will explain you what is this xk represent, what is this yk represent. Generally, you know, we are calculating the value of y for a given value of x, where x is not listed in the table. But when you are calculating the value of y for a given value of x, where x is not listed in the table, but this x which you want to go for interpolation, your x is very close to a value of x which is present in your table, right? So your xk is the value of, I would say, which is very close to the value of x for which you want to go for interpolation. So xk is the value which is very close to the value of x for which you want to go for interpolations. And yk is the corresponding value for y, because y is a function of x. So y is the corresponding value of xk. So for corresponding xk, you have value of yk is you can find from the table. So xk and yk are given values in a table. H is the common interval of x, which I have already mentioned. So which we can see now, this H is simply, you can look at your table. So h is basically x1 minus x0, x2 minus x1, x3 minus x2, x4 minus x3, x5 minus x4. So h is known. Similarly, I can also write down this expression that your x, which is you want to find y, you want to find the value of y for a given value of x. So your x is basically, it can be written as xk plus h into u, where u is can be calculated using this formula x minus xk divided by h, right? So now you can see, so then a value of y for x which is not contained in the table is given by Newton's interpolation formula, right? Which is having equal spacing. And this formula, which I wrote here, you see, I write this formula number 3, where y, that is the value of y, which you want to calculate for a given value of x, which is not listed in the table, is yk plus u delta yk plus u into u minus 1 upon factorial 2 del square yk plus u into u minus 1 u minus 2 upon factorial 3 del cube yk, and you have del 4y4, del 4yk, del 5yk, and finally you can write the final term, del to the power of rth order difference, del to the power of ryk. Dear friend, the derivation of this Newton formula, equation number 3, is given in the book which I have already mentioned. And please refer the book Numerical Methods by B.S. Grewal. This book is published by Khanna Publisher. It is a very famous book and very popular for the numerical methods. I hope the numerical analysis you have studied uh, in your maths paper, your math syllabus is also covering numerical analysis. So probably your maths teacher must have derived this expression. So I request you please refer your textbook as well as some references and look at the derivation part. Generally, this is a computational exercise. So we are generally not asking the derivation part. We have to go for interpolations and you have to solve various exercises. So here we will not derive this expression. And now you see here I said that xk is the value in a difference table which is very close to the value of x. So which is already I discussed. And x is a value to be interpolate which is not present in the table. So once again you please remember your xk is a value which is present in the difference table which is very close to the value of x, and x is a value to be interpolate which is not present in the table. You see, this is the forward formula. Why this formula is known as a forward interpolation formula that we will discuss when we actually solve the problem. Generally, see, said that when the value of x which is to be interpolate is lying in the beginning value of, let's say, if it is lying in the beginning value of the x, these are the beginning value x0, x1, x2, x3, or it is lying at the beginning of the table, I would say. Then you have to use your interpolation formula, the forward interpolation formula. And if the value of x which you want to interpolate is lying at the end of the say at the end of the column, you see, that is x4, x5, x6, correct? uh, right? It is not like in the beginning value of the x. Then you have to use the formula which is known as the backward interpolation formula. We'll take the example, then you will get the clarification what I mean to say. So you see here the formula which I wrote here. I'm sorry. So this formula number three is a forward formula, right? And you see the second formula which I write is second useful formula for obtaining the value of y for a given value of x. For you see where your xk, no, xk, which is very close to x, is lying at the end of the table. You see here, if your xk is lying at the beginning, you see at the beginning of the table, then you require a forward interpolation. And if xk is lying at the end of the table, and this is the table, that is the column, I would say x column, and then you use the backward formula. So now this formula, which is formula number 4, which I wrote here, you see yk u delta yk minus 1 u into u plus 1 factorial of 2 del square yk minus 2 u into u plus 1 u plus 2 upon factorial del cube yk minus 3, and finally I write the rth order difference del to the power of y r yk minus r. You can write this formula, and you can I think you have to remember this formula. These formulas are important, and I request you to remember this formula. In examination, sometime your examiner may not give you the forward interpolation formula or backward interpolation formula. Then you people have to remember these formula. So remember formula number 3 and formula number 4 to interpolate a given value of x. Here, first we will take an exercise to understand this. You see, this paragraph, uh, it should be noticed. It is very important. In equation number 3, involves a difference is lying on a diagonal line in the table starting from yk. While equation number 4 uses the differences on a horizontal line from yk. Thus, equation should be used for interpolation near the beginning of the difference table, and equation 4 for the equation number 3 is used when your xk is lying near the beginning of the difference table, and equation number 4 is used when your xk is lying at the end of the table, that is the beginning which I want. So now I will explain you the diagonal element as well as the horizontal line which we will see. So when you use equation number 3, so if you see, this is suppose this is your xk. So our xk is x1. So this is your yk. So if you draw a diagonal element, so your diagonal will be del y1. Then it will be del square y1. Then you have a del q y1. You will have a del 4 y1. you have a del phi y1. So when you use the Newton forward interpolation formula, then this diagonal element will appear in the interpolation formulas, that is starting from yk. So you first find out xk and yk. Suppose your x is very close to x1, so your x1 is your xk. So this y1 will be corresponding to xk, it will be yk. So once you know yk, you draw the diagonal line. So if you draw the diagonal line, then is y1, then you have a del y1, del square y1, del q y1, del 4 y1, del phi y1. These differences, that is this first order difference, second order difference, third order difference, fourth order difference will appear in the Newton's interpolation formula. And you see, when your value of x is lying at the end of the table, suppose your x is a line, suppose your x is very close to x6. Suppose your x is very close to x6. So your xk will be equal to x6. So this will be your yk. So when you are using the backward interpolation formula, then from yk you draw a horizontal line. So if you draw a horizontal line, this difference is del y5, del square y4, del qy. This will be this term, these differences will appear in the difference table. So that we will see when we solve the problem. So look at the first problem which I have selected here. So once you understand the forward interpolation and the backward interpolation formula, let us solve the problem number one, example number one. Uh, this example is that you have some function y is equal to e to the power of minus x square, exponential of minus x square is given, and for a different values of variable x, right? This is a the corresponding values of y's are given, these values are given. And so this is your x is changing from 0 to, you see the lower limit is 0, the upper limit is zero point 0.3, and your interval size, you see the interval is 0.05, 0.10. So you can see the h is 0.05, right? So interval is constant. You see how you have equal spacing, is equally spaced. So this is the special features, that if equal interval is equal, then and then you can use a Newton's interpolation, forward interpolations or backward interpolation formula. And this is your y is 1.00. This is your x0. So this is your y0. This is x0, y0, x1, y1, x2, y2, x3, y3, x4, y4, x5, y5, x6, and y6 are given to you. Now you have to interpolate. Uh, what is the formula? You see, you prepare the difference table, and using Newton's forward interpolation formula, find y for x equal to 0.0477. So here you see x, you want to find y for x is 0.0477. So you see this value of x is not mentioned in the table. You see 0.0477 is not listed in this table. But of course, this 0.0477 is very close to 0.05. Look at this. Your 0.0477 is very close to 0.05. So since your xk is lying at the beginning of the table, right? It is lying beginning of the table, we can use forward interpolation. So we have to use the forward interpolation. So your xk is what? Xk is 0.05. What is yk? So yk is this, for corresponding value of this xk you have yk is 0.9975. So xk is this. So what is the index k? This is x0. So k is 0. Here it is x1. So k is 1. Is it okay? X1. So it is xk. So k is 1. So this is yk. So k is 1. This is y1. So your xk in this problem is x1 and your yk is y1. So this you please remember. Okay. So you will have your y1. So this is your xk, this is your yk, and now I use this formula. You see, I first prepare the difference table first. You see, the table which I have already mentioned. You have to prepare this table. You write down the value of x0, x1, x2, x3, x4, x5. Write down the corresponding value y0, y1, y2, up to y6. So you see, this is already I have mentioned here. So look at this, which I have prepared the table. So table is prepared here. This is x0, y0, x1, y1, x2, y2, x3, y3, x4, y4, and this value I have mentioned. So look at this. I have mentioned this x0, y0, x1, y1, x2, y2, x3, y3, x4, y4, x5, y5, x6, y6 is already mentioned. Then you find first order difference. Del, right? So first order difference, you see, I write down it is difference same here. The difference del to the power of 1. So del to the power of 1, which is we calculate here. So look at this table. I calculated del y0. Del y0 will be equal to y1 minus y0. This is del y1. Del y1 is, you see, this is y0, y1, y2 minus y1. Then similarly, you calculate the difference table, del y2, del y3, del y4, del y5. So you del y5 is y6 minus y5. So you see I have calculated this. So here I have calculated this table here, and you can see I took care about the sign. This is y1 minus y0, right? Del y0, this del y0 is y1 minus y1 is 0.99750 minus 1.0. So you see there is a minus sign. You have to take care about the sign, right? And so you find del square, del square y0, del square y1, del square y2, del square y3, del square y4, like this. Del q y0, del q y1, del q y2, del q y3. So these are the all table which you have to find out this. And I have mentioned how to find del 3 y0, del 4 y4, del 5. So this table you have to prepare by taking care about the sign. So you see I have prepared this table. And these people, right, preparing the table, I use that multiplier because the term is very small. So I write in a scientific notation of the order of 10 raised to minus 2, 10 raised to minus 2. So this is into 10 raised to minus 2. So this is minus 0.745 into 10 raised to minus 2. So I write the multiplier here, uh, right? Del second order, third order, fourth order, fifth order, and sixth order. Sixth order is 10 raised to minus 5. Yeah. And now I use the interpolation formula. And you see in this case, your x is 0.0477. So your x is very close to the value of table zero point zero 0.05. So zero point zero 0.05 is xk. So yk is 0.99750. And your index k is 1 because this is x1. So k is 1. X equal to xk, and xk is x1. Y equal to yk, and k is 1. This is y1. So your index is 1. So right, so that index you please remember. So now I write down the formula. You see I calculated the u. Variable u is x minus xk upon h. X you know, xk is which we have calculated from the table, right? And h is the interval size, so we calculated u. And now once you calculated the variable u, I wrote this formula see explicitly. Yk plus u delta yk, second order difference, third order difference, fourth order difference, fifth order difference, sixth order difference. This is already mentioned here. You see, I write down this formula number 2. You see, this is del q y del q y k. Now our formula where k is 1, right? We have a k is equal to 1 because we have x is xk, xk is x1, so k is 1. So our formula appears as y equal to y1 plus u delta y1 plus u into u minus 1 factorial del square y1 plus u into u minus 1 u minus 1 del q y1. Then del 4 will be equal to u into u minus 1 u minus 2 u minus 3 upon factorial 4 del 4 y1. Then you have a del 5 y1 del 6 y1, which you can using this logic you can write this formula. So you see I wrote this formula here while considering the all fifth order term, and where your yk, please remember your yk is this is y1. This is y1 u delta y1. This is del square y1. This is del q y1. So you know del y1. So del y1 you can calculate from this formula. Del y1 is here. This is del y0. So this is del y1, right? This is del square y1. This is del q y1. This is del 4 y1. So you see, once you know yk, and if you draw a diagonal line, right? So this is, you see, this is 0.997. And if you draw the diagonal line, so this is first del y1, right? Then you draw the diagonal line, extend the diagonal, del 2 y1, del 3 y1, del 4 y1, del 5 y1. And like this, you can carry on and you can see these element del 5 y1, and finally you can write these diagonal elements. And that's why you see that interpolation formula which I mentioned here. You see u del y1 del square y1 del q y1 del 4 y1 del 5 y1 del 6 y. These are all diagonal elements. So you put these all values in the table. So using the difference table and Newton's interpolation formula, we get y. This y equal to 0.99772 for your x, which you have interpolated is 0.0477. So this is the way you can interpolate the Newton for a given value of x, which is this x was not listed in the table, but we have interpolated. Similarly, you have to find out for x, let us say for x is 0.2862. We have the second, you see the same problem which is given. You using the difference table and Newton's backward interpolation formula, find y for x equal to 0.2862. Now this is 0.2862. This is the x, right? Which is not listed in the table. You see, 0.2862 is not listed in the table. But of course, this 0.2862 is very close to 0.30. So this 0.30 is the value of xk, which is very close to x. So your xk, this xk, you see, is 0.30. So what will be yk in our case? Yk will be 0.91393. So now you see the index. This is x0, this is x1, this is x2, this is x3, this is x4, this is x5, this is x6. So k is 6. Okay, your index k is 6. You have your xk, x6 is your xk, your x6 is your xk. So k is 6. This is yk, y6. This is k is equal to 6. So now when I use my Newton's backward interpolation, wherever k appears, I have to write down k is 6, right? And your xk is 0.30 because your x, which is to be interpolated, is very close to 0.30, and because your x is lying at the end of the table, it is not lying at the beginning of the table, it is lying at the end of the table, we have to use Newton backward formula. So I use a backward formula. You look at the backward formula. So when you use this backward formula, you see, I can write this backward formula. You have the yku delta yk minus 1, then you have a del square yk minus 2, a del q yk minus 3, like this. And now you see k is equal to 6. So this is del y5. This is del y, right? Del y5, del square y 6 minus 2, 4. Then you have a del q y3. So these are the elements which these elements will be the element. These are the horizontal element. You see, when you find yk, you see this yk here. Once you find your yk here, suppose this is your yk x6, suppose this is your yk x6. So this so once you know yk, then these elements del y5, del square y4, del q y3, del 4y4 y2, del 5y1, and del 6y0 will appear in the Newton backward interpolation formula. In a forward interpolation formula, once you know yk, you draw the diagonal element. All diagonal elements will appear. The difference lying on the diagonal line will appear in the Newton's interpolation formula. Here, one for a backward interpolation formula, once you know yk, you draw the horizontal line. All the differences lying on the horizontal line, del y5, del square y4, del q y2, del 4 y2 will appear. This you can verify because it is y6. You see the formula, this formula. So you see this is y6. So you know y6. Then y5, this is right, this is y5. Then y4, del square y4, del q y3, which are appear. So these are the elements which you can see. del y 5, del square y 4, del cube y 3, del 4 y 2, del 5 y 1, del 6 y 0 will appear in the backward interpolation formula. And once you use this backward interpolation formula, once again you see I have calculated this backward interpolation formula, and you can see this formula, and I use the difference table and backward interpolation. I find y, the value of y I got it 0.92135 for x equal to 0.2862. You see this, you can verify, because for zero point 0.3 your value is 0.91393. So naturally your value must be less than 0.91393, which you can see here. So this value is zero point 0.9, zero point 0.9, the value is 0.92135, which you are getting, and here you see this is 0.93. Uh, right, 0.3, 0.91393 is the value of xk, and for 0.28, which we are getting point y I'm getting 0.92135. This you can see that 0.92135, you see, is slightly greater than 0.91393. I think you please verify uh, this answer. I think you please do this calculation, then check my answer, right? So you please verify this answer. Uh, uh, so I request you to please verify the value of y which I have calculated here. Okay, here you can see the first value which we have calculated for 0.0477. It is 0.99772. You can see here. So this is the value for point zero 0.05. For point zero 0.05, the value is 0.99750, and our value which we have calculated should be less than 0.99750, and the value which we have calculated is 0.99772, uh, which is very close to the answer. I think this is okay, but I request you, you please verify this value of y which I have calculated uh, uh, for x equal to 0.2862. You please verify the answer. Now I am giving you this exercise, that the following table, this table gives the distance in nautical mile. This is the distance which is given in a nautical miles of the visible horizon for the given heights, which is in feet above the earth surface. Find the value of y, this, find the value of y when your x is 218 feet and the other value of x is 410 feet. So you have to interpolate this x. You see here the x is 218. So this 218 is very close to, you see, 200. So your xk is 200, which is lying. So your xk is lying at the beginning of the table. So you use for Newton forward interpolation formula, and here I use x is equal to 410 feet, which is very close to 400. So here your xk is 400, right? So here you can use the backward interpolation formula and find out the value of y when x is 218 feet and x is 410 feet. So this is the exercise which you have to perform in your laboratory session. So when you prepare your journal, you write this exercise, you write this problem, which is I have calculated. Example number one, you have to write this example number one in the journal with these different tables and with these calculations. I request you to verify the value of y for a given value of x equal to 0.2862, and then you have to solve this exercise and interpolate this x for the forward interpolation, and in this is for the backward interpolations. So you have to include problem number one and exercise number one in your journal. Right at the same time, we have another Lagrange formula we have to use when the value of x are not having equal spacing. So when you have the value of x and when the interval is not same, when the interval is different, then you have to use the Newton's interpolation formula for unequal interval. So I have the another interpolation which I would like to explain, that interpolation for unequal values of the argument, that is having a step size interval is not equal. So when the value of x are given for unequal intervals, equation 3 and 4 which we have used are not applied. So it is possible to use the interpolation method, but the method we will use the Lagrange interpolation method. So for Lagrange interpolation method, once again, you have a function y. Suppose y is some function of x. Okay, let us say y equal to e to the power of x, or y equal to e to the power of minus x. Well, like that function is there, where x0, x1, x2, xn, and y0, y1, y2, yn are known, right? Then for some other value of x which is not listed in the table, suppose the value of x which is not listed in the table, you can interpolate this x. You can find y for the corresponding value of x which is not listed in the table using a Lagrange interpolation method for unequal interval. Is this is the formula. You see y is a function of x, where you have x minus x1, x minus x2, it will go up to x minus xn. Suppose you have xn is n equal to 3, so you have to go x minus x1, x minus x2, x minus x3, right? So you have this first term into y0. The second term you see x minus x0, x minus x2, x minus xn, and the denominator is x1 minus x0, x1 minus x2, x1 minus y1, right? So you have y1, y0, y1 plus y2 plus y3, and you have to go up to yn. This is the first term y0. Then the second term have a y1, then you have a y2, right? Then you have a y3, and you have up to yn. So this formula, the derivation is given in this Greval book, which I have already mentioned. Here we have to use this formula because we are performing a computational exercise. So we are using this formula. So now you look at this example given to you, that you have a thermocouple experiments, and the following data are obtained in the calibration of a platinum rhodium thermocouple, and you have to find the temperature corresponding to the reading of 9 millivolt. So these are the results given to you. This is x0, right? X0 is 5.531. This is your X1, 9.117 is given. This is your X2 is 10.301. So this is your X0, this is your X1, this is your X2. Your N is equal to 2. So you have to go up to this Y0, Y1 and N equal to 2 equal to Y2. So if you put Y2, so it will be X0, X minus X0, X minus X1, minus X minus X1. Here you see up to X minus X because 2 minus 1 is, so you have to write X into X minus X2, X minus X1 upon X2 minus X0, X2 minus X1, and you can write this because N minus 1, so you have to go up to X1. So for N equal to 2, the 2 term will appear. X2 minus X0, X2 minus X1. This you can understand. So you see, I wrote this formula. You see, the first term is Y0. So the Y0, and what is the coefficient? Because N is equal to 2. So it will be X minus X1, X minus X2, you see, because you have to go for N equal to 2. Similarly, in the denominator, X0 minus X1, X0 minus X2. So it is Y0. Y1, this the coefficient of Y1, you have to go for N equal to 2. So it will be X minus X0, X minus X2 divided by X1 minus X0, X1 minus X2. And here we have N is equal to 2, so it will be Y2. What will be the coefficient of Y2? Coefficient of Y2 will be 2 minus 1, so you have to go to up to X1. So it is X minus X0, X minus X1 divided by X2 minus X0 and X2 minus X1 and into the Y2. So this is the formula. And now you see, you can put the corresponding value. You want to find Y for a given value of X. Your X is 9.0. This is the value which you want the value of Y, that is you want temperature corresponding to the thermo EMF 9 milliwatt. So this is your X. Your X is 9.00 milliwatt. So your X you have to write down here. So X you write down wherever X appear you write 9. X1 is known to you. This is your X0. This is your X1. This is your X2. Y0 is known to you. This is your Y0. This is your Y1. This is your Y2. So put the value of Y1, put the value of Y0, put the value of Y2. Wherever X1 is appearing, you put X1. This is your X1. This is your X2. You put this value, and when you put this value here, and you see, I mentioned here X0. You see, X0 is this, X1 is this, X2. I have mentioned X2 is this. I have mentioned Y0 is 6 point. This is in centigrade. Y1 is also mentioned. Y2 is also mentioned. So I substitute this value, and I get the Y equal to 950.4 degrees centigrade. This is at 9 millivolt. You see at 10 millivolt, the thermo EMF, I'm sorry, at 10 milli, I'm sorry, at 10 millivolt, when thermo EMF is 10, the temperature is 1063 naturally. So your 9 millivolt, your temperature of the junction should be less than 1063, which is you can see it is less than 950.4, which is less than 1063, which you can see that this is basically the correct answer. Now you can, this formula is used, and we can change the variable x and y. You see, so we can interchange the variable x and y in this equation 5. So wherever x appears, you can y. You see here I have interchanged this form. So when you have a function x is equal to f of y, you see, this is, I write this formula for y is a function of x. Here I write a formula where I can see x is a function of y. And so I can simply, you see, wherever x appears, I change x to y. So you see x is y minus y1. You see here x, wherever x appears, I interchange. Instead of x, I write y, and instead of y, I write x. So I have the invert formula. There is a inversion, you can see. So I write this formula. Now uh, I can use, see, there is a problem which you can use this problem like this way. You see, you can now find EMF, you see, for a given value of temperature. So using this equation, we can find the EMF corresponding to temperature 750 degrees centigrade. In the previous problem, you see your value of X was EMF, right? But now in this problem, we have your X is temperature. You see, here you see you want to find out thermo EMF corresponding to the temperature reading 750 degrees. So now your X is not thermo EMF, but X is your thermo temperature of the junction. So this your X is now 750. So once again your X0, X1, X2, Y0, Y1, Y2s are same in the table. So you substitute in which formula? The formula which is an inverted formula. We have inverted this formula and you write down Y, Y1 and the formula which you see this formula. So here you see the, if you put the corresponding value here and find out the value, and you please remember that Y is 750 because you see uh, in this case we want to find thermo EMF for corresponding. So this is your 750. Your 750 is now your Y, and corresponding your uh, X0 is known to you, X1 is known to you, X2 is known to you, Y0, Y1, Y2 is known. So you know the Y is 750. And now you substitute in this formula, in this formula, this Y, you will get X. That is the value which we have calculated. See, so in this case, X we get the thermo EMF is 6795, and that you can verify. Now you see for 750, right? And so for 750, you will look at the table as a 750 temperature. So now you see 750. It should be less than, this is 630. This is 960. So it should be less than 9.117 milliwatt. So let us see. So you can verify. So the answer is 6.795, which is less than the value which at 9660, and greater than 5.535, because that is related to the temperature 630.5 degrees centigrade. So you have to use the Newton's, Lagrange interpolation formula for unequal interval, because you see this interval, look at this interval which is given. If you take this value of X, you see this is 5.535, then 9.117 at 10.30. See the interval, this x1 minus x0, right, or x2 minus x1, they are not same. Interval is not same. Similarly, you see this y0, y1, y2 also. So this is used for unequal intervals. So we have discussed the two different methods: Newton's interpolation formula, forward as well as backward for having equal intervals, and Lagrange interpolation formula for having not having equal intervals. And now this problem which it is given, this example number 2, you have to include in the journal, and you have to also solve uh, the exercise which is given to you, that you are given the values of x as well as fx. X and y is given. Y is a function of x. You are given value of x and y, and you evaluate f of 9, right? When x is equal to 9, you find y. F of 9 is y using the Lagrange formula. So this formula you use the Lagrange formula and find out the value. You see the interval. Look at the interval. 5 minus 7 minus 5 is 2. 11 minus 7 is 4. 30 minus 11 is 2. 70 minus 30 is, so this interval is not same. So please solve this exercise number 2 also. So this is your exercise number 1, and exercise number 2 you have to solve. You have to write in your journal. I will upload this lecture on the Moodle, as well as I will give you the assignment, where in the assignment you have to solve your exercise number 1 and exercise number 2. So when you download the assignment, you will get a complete note of the interpolation method. The complete note, you will get it to refer the topic of Newton interpolation as well as the Lagrange interpolation methods, and the both the problems you will get it, exercise number 1 and exercise number 2, that you have to include in your journal. So I hope you will do this exercise. If you are having any problem, you please write me a mail, or you can have the forum. You can put your query in the forum session. I will solve your questions, your doubts also. So I will stop here, and once again, I thank you for listening me. Thank you very much.